that's that. That's the deal. So let's talk about the different cases that we can have. Again, we are fixing our eyes upon Jesus. Fix my eyes on you. Okay. Anyways, but we are fixing our gaze upon this equation here. What is delta G? It is the change in free energy in our system. What is delta H? It is the change in enthalpy. What is enthalpy a measure of? Change in heat. So, thermal energy related to enthalpy, which is related to heat. Okay, so is our reaction going to absorb heat? If so, then we're going to have to provide some extra energy here in order to do so, maybe with the temperature. Okay, if our reaction is going to give off heat, maybe we don't need extra energy to come from this part. Okay? What does T stand for? Not the gossip that I hear every day while sitting in my office.
What? Gossip? At a Christian school?
That's right. T stands for temperature. What are the units? Kelvin. And delta S. S is a measure of entropy, which is a measure of disorder. So change in disorder.
Didn't you say like Celsius is a waste? So why is it Kelvin?
Celsius is a waste, which is why we use Kelvin.
So why is that in Kelvin and not Celsius?
Because Celsius is trash.
But I thought you liked Celsius.
Celsius is better than Fahrenheit.
Oh.
Because Fahrenheit is just made up. Celsius is almost related to real life, and Kelvin is actually useful. Here's the real reason why we have to use Kelvin, because there are no negative numbers.
Oh.
So the only way, we're going to talk about the different cases here of positives and negatives. Wake up! You got it. 10. Like positives and negatives and how this could work out. But the big thing is your temperature can only go up. It can only get hotter. But this will never be a negative. Okay? So, we have, bye kiddo. She's having life issues here. Okay. So, all right, so let's make a table here. We'll look at a couple of different cases. If our reaction is exothermic, is delta H positive or negative? Exothermic, it lets off energy. Delta H is negative. So, if we have a negative delta H, and we have a positive delta S. Does it matter what temperature we're at? If this term is negative, our temperature is always positive, and this is positive, what type of number are we going to get for delta H? Is it going to be positive or negative?
Depending on how.
If I have a negative number here,
So it's negative?
and a positive times a positive here, this is always going to be negative. If you don't believe me, plug in like 5. I don't know, who cares? 5 times 5. This always going to be a negative, right? As long as this number is negative and this number is positive, we will always get a negative number out. So this is spontaneous, always. So as we were solving that out, we found our delta H, we found our delta S in our homework problems from last night. In the first reaction, we had a negative delta H and we had a positive delta S. That reaction is always going to happen spontaneously. No toys in class. Thank you. That will always happen spontaneously, doesn't matter what temperature. Just do it on the Don't care. Always spontaneous because this term always ends up negative. Now, let's look at this case. If we have a negative delta H and we have a negative delta S, when will it happen spontaneously? Let's check the things here. So I have a negative. How do I get this to happen spontaneously? Does the temperature have to go up or does the temperature have to go down?
Down.
So remember, delta H and delta S are fixed for any given chemical reaction. So in order to make this work, temperature has to go down, so this term goes away and gets smaller and smaller, and then overall the delta H can take over. So I need low temperatures if I have a negative delta H and a negative delta S. So I'd be looking for a lower number in order to make it happen spontaneously. So sometimes you have to cool something in order to make it happen. Okay? What if we have a positive and a positive? Now we have positive 5 and positive 5. Will this happen spontaneously?
It depends on the temperature.
It depends on the temperature again. What kinds of temperatures do I want?
Higher.
This is really important. If you crank the temperature up, overall, this becomes more negative. So if I picked 1 for the temperature, it would equal 0. If I picked 10 for the temperature, it would be what? 5 minus 50, which is negative 45. So as I increase the temperature, it will be spontaneous. Now here's the last case. This one's a little tricky. What if I have positive and negative? So we're doing positive and a negative number in here. Will this ever be negative?
No.
No, because if you add a positive number to a positive number, it'll never be negative. So this reaction will never be spontaneous. Now, it might sound like I'm saying it will never happen. That's not true. What I'm saying is that we're going to have to do other things with those reactions in order to get them to happen. We may have to add an enzyme that breaks down some of the elements, and then we can make the reaction happen. We may have to change other conditions that aren't temperature in order to make this happen, maybe higher pressure or lower pressure. But we can't do it using temperature. Okay, so those are the 4 different categories just based on this equation alone. So if you love math and math is your favorite thing and you wake up in the morning and you're like, woo, math, then this helps you. If not, maybe memorizing the table will help you get to the right answer better. Okay. But there will be questions where I say, here's the chemical reaction. At what temperature will this be spontaneous? Some of them will be, it's always spontaneous. Some of them will be at temperatures below this temperature. Some of them will be at temperatures above this temperature. And then some of them will be, this is never going to be a spontaneous reaction. So let us try this one. Calculate the Gibbs free energy change for the following reaction. Okay, go ahead. You'll need your tables. You have to find delta H and delta S. The table is still on page, surely print these out for you, 352. Fact?
What's that say? Never mind.
I'm going to do that right now.
What does it say at the end?
You make it 298 Kelvin.
Okay, thank you.
Which one are we finding, H or F? HS or G?
What?
G.
Yeah, where's the table on?
It's in the,
250. What page?
yeah.
So you were thinking. Really? Yeah, I was like, I didn't ask what book you
Yeah. But are you sure?
Yeah.
Positive?
No, it's,
Same.
0.
Wait, 252.
Do we?
It's for, no, that's for the temperature for the equator.
No.
These pens really are annoying.
They're just bullying you.
Oh, yeah.
Don't worry, I'm gonna like.
And then the next
We
one
can
is
get those
202.
pens.
Pushing to right there.
From,
What is it? 227.
okay, so we have to figure out both of them and then fry
Yeah,
a little
okay,
bit.
delta H and delta S.
We have to figure out both of them.
This one's delta H, right?
Why is it like this? For torture purposes.
Ryan, yeah.
Excuse me.
Okay, what are the steps? Find H, find S. Great. So what is H for carbon?
What?
H for carbon is
0.
0. It's elemental, so 0. What about hydrogen gas?
0. 0.
Still 0. How about C2H2?
227.4.
227.4. What are the units? Kilojoules per mole. Okay, what are the S values for carbon? 5.7. Hydrogen gas? C2H2? 200.9. Joule per mole Kelvin. So with that information, you can calculate delta S and delta H. Go ahead, calculate them. I've done all your work for you. You got this. What this?
Yeah, I'm so sorry.
Are you though?
No.
The Bible says something about God putting a song on our heart, so I don't know.
Well, yeah. I feel like
key.
If there's no music playing, then obviously. He's gonna put Kershon on. I know. And then we're gonna have to listen to I Can Only Imagine on repeat.
Do we?
Nope.
which ones do we have to do first?
You have to convert one of the
But we want it in jewels, right?
Doesn't matter.
Okay. Okay, key to my heart really needs to like. There's some lyrics in there that I'm like.
God
what is
bless.
Fine, son. I don't know.
that the one that says you are good? That's the only part.
Oh.
That's the only part that is
Okay, delta H is. There's only one mole of this, so 227.4 kilojoules. Delta S is what? Multiply this one by 2. Multiply this one by 1, this one by 1. So that is products minus reactants.
You add them together? You don't multiply
Is
them?
kilojoules
Ah.
3
Kilojoules, yeah.
What's delta H then? Like how do you find that?
Products minus reactants.
Wait, so that's the same for like as S?
All the deltas are product minus reactant. Okay, so we have 200.9 minus 2 times 5.7 and 130.7. So delta S is 58.8 joules per mole Kelvin. So we can already predict what's going to happen. Delta H is positive, delta S is positive. When they're both positive, well, no prediction. It might happen. So let's go ahead and solve for delta G. What's the equation? Delta G is delta H minus T delta S. That's the temperature, not the T. So we have 227.4. I'm going to convert this to joules because it's easier. Minus 298 times 58.8. This is a really big positive number. What does that tell us? It is not going to happen because this is positive. Follow-up question. At what temperature is it spontaneous? How do we figure that out? We set what equal to 0? Set G equal to 0. Delta H is a fixed number. T is the only thing we can change. And you solve for T. So the temperature at which it would be spontaneous is 3,867 Kelvin. It's very hot. Thank you. Why do you have to look at his computer for that?